I am back to do a deeper dive on this paper that talks about thought preference optimization, which is a way to train LLMs to think. This paper comes out of Meta's research arm. Now, if you want a little bit more context on why this paper is interesting and why it matters, check out my channel to watch that first initial video. So this is a really good graphic that covers exactly how thought preference optimization works. You're going to start with this LLM that you want to train to think. Next, you're going to give this LLM that you want to train these different user instructions. Now you're going to ask the LLM to respond to that user instruction. But before you do that, you're going to tack on this additional prompt so that you actually prompt the LLM to think before it responds. So now the LLM is going to spit out its thought process as well as the actual response to the user instruction. You're going to have the LLM come up with a couple different responses for that same exact user instruction. So now you're going to have multiple different versions of LLM responses that include the thought process as well as the responses. Now we're going to go into this process called RLAIF, which stands for Reinforcement Learning from AI Feedback. This is kind of similar to RLHF, Reinforcement Learning from Human Feedback, but in this case, you're using AI to provide that feedback. They call this AI a judge model that essentially judges the responses. Now note that the judge model only judges the responses because there aren't actually that many judge models that can fairly judge an LLM's thought process, and there isn't actually that much training data out there to even train a good judge model that knows what good LLM thinking looks like. So instead, they focus on those responses. The judge models they used come from other research papers. Now, using these judge models, we create these preference pairs where we pair the highest scoring response with the lowest scoring response. And that gives us those preference pairs that we need to do reinforcement learning. Now, what they did in order to update the models in an iterative process was DPO, which is a really common way of updating models to align it better to the preferences that you're trying to get it to align to. And all of this together allowed them to create a model that thinks before it responds.